to find the modulus and the argument of the complex numbers. Okay, let us say, the complex number is represented as z. Okay, we represent generally it by z. Okay, and this have two parts, the real part and the imaginary part. With the imaginary part, and I alphabet is always introduced. Okay, so this is the complex number. Okay, now what is the modulus and what is the argument? Okay, so my dear friends, a complex number z equal to x plus iy can be represented by a point whose coordinates can be considered as x and y. Okay, so this will be a unique point only. Okay, and this will be represented on a Argand plane. We can say it as a Argand plane, we can say it as a complex plane or Gaussian plane, right? It's an Argand plane or it's a Gaussian plane. We can also say it's a complex plane. Which plane? We have learned from our very beginning in your classes, the x and y axis. Okay, just represent it, and this is the plane where the x and y plane where any complex number can be represented. Okay, so let us say z equal to x plus iy is your complex number. Okay, then you can see this is the y coordinate and this is the x coordinate, and if this is represented by a point, if this complex number is represented by a point p over here, let us say this is the point p, right? Then the coordinates of this complex number will be x and y, isn't it? And if you see the distance of point p from origin here, origin, so this will be like this. If you draw a perpendicular line over here, so this will be the, let me extend it somewhere over here like this, right? So this will give the x coordinates, this one, and this will be the length of y coordinates when you draw perpendicular here over here. So this will be y, right? Now when you just connect O to P like this, as we have did in our vectors, the resultant, okay, or the right angle triangle by using the Pythagoras. Okay, so all this, so the length of OP is your modulus. So modulus of a complex number z can be represented like this. The mod sign will be implemented over here, and this will be the length of this resultant vector, or resultant, we can say the hypotenuse of that Pythagoras, by Pythagoras in the right angle triangle. If this is 90, we have considered this triangle, right? Sorry. So if you remember, we just calculated the length of the hypotenuse as root over of x square plus y square, or the resultant vector, right? So just I want to say the resultant vector or the Pythagoras just to recall, and in this way we are always finding the modulus of a complex number. And what is the value of the modulus number? What is the, this is the modulus, in which in this way we will find the modulus of the complex number. And what is the argument? For argument, my dear friend, what is the argument? For the argument, this will be the angle, this will be the angle with which the modulus is making, and this is the angle theta. So argument of the complex number z is equal to tan theta. Argument of complex number z is basically theta, right? And which can be represented as, if you take tan theta, then tan theta over here is y by x, right? Y by x. Tan theta is y by x. So from here we get theta, as equal to tan inverse of y by x, right? So this is your argument, right? This is your argument, my dear friends. Now let us solve quickly few questions so that we can understand these two concepts of modulus and argument. Okay. Now we will also see how to represent the complex number into the polar form. Okay. So quickly taking up a question which I put in my source yesterday, question number 1 for today, that if the complex number given to you is z equal to 1 plus I, right? Is given to you as z equal to 1 plus I, right? So how to find the modulus of this? Definitely, if you put z in any complex number into its standard form x plus iy, just recall here this is the standard form, if you recall it, this one, right? Then z can be represented equal to x plus iy, and what will be the modulus? This will be the modulus, which is equal to mod z equal to root over of x square plus y square. What is the real part over here? Real part over here is 1, so it will be 1 square. And what is the coefficient of imaginary part? If nothing is there, only I is there, then definitely 1 is present over here. So we can write it I into 1, right? So this one will be coming over here in place of y, and this will be 1 square. So we can say that root over 1 square plus 1 square root over 2. Root over 2 is the modulus of z. Okay. And what is the argument of this complex number? In this way z modulus is calculated. And what is the argument? Argument is nothing but, argument of complex number z is nothing but theta. Theta is this angle where y by x, tan inverse y by x, right? So this can be written as tan inverse y. What is y? Y over here is 1, and x over here is also 1. So 1 by 1 is nothing but 1. And what is the, when tan theta is 1? Tan theta is 1 at 45 degree. So we can say that yes, theta equal to 45 degree. Or we can also write it as pi by 4. So this is the argument of the complex number, my dear friend. Okay. It's very simple. It's a very simple calculation. Okay. So in this way, we can see the modulus and argument of a complex number can be found, right? Now if you want to let us see how to represent this into its polar form. Okay, to represent it into a polar form, what is the polar form? To represent the above complex number into its polar form, if you remember, this can be written as polar form of the complex number z can be represented as modulus of z, then cos theta plus I times sin theta, right? As you see in the base and perpendicular, the same over here, right? What is the modular? Just remember this one, the polar form. This is z equal to cos theta plus I sin theta, right? And modulus of z over here is root 2, right? Root 2, and cos theta. Cos theta is, if theta, the argument is considered as pi by 4, right? Then it will be cos pi by 4 plus I times the argument, sine of argument, that is pi by 4. So in this way the polar form can be represented for any complex number, right? Now if you want to take more questions for the modulus and argument, we can take it, okay? But try to understand that what is the basic understanding. Simple. As we seen into the coordinate, as you seen into the coordinates, what are the value of x and y, what is the resultant one, okay? How we are calculating it, that we learned, right? Now let us take few more questions quickly. Let me take it from the NCERT only. Okay. If the complex number given to you is 1 plus I, question number 2, is z equal to 1 plus I by 1 minus I. right? If this is the complex number given to you, then what is the modulus and what is the argument over here, right? So, my dear friends, for any complex number which is given into the form 1 plus I by 1 minus I, this is not the standard form. Just convert this complex number into a standard form where we have one real part and one imaginary part. For the real part, this will be x. If you consider for z equal to x plus iy, for the imaginary part I will be there, right? And this will be the coordinate of the y, right? Like this. So any complex number should be represented into its standard format before going into a calculation of modulus and the argument. Okay, so here 1 plus I by 1 minus I is not into the standard format. So what we will do, we will just convert into its standard format, into this format, right? How? Z equal to 1 plus I by 1 minus I, right? As we did into the rationalization, if you remember, right? What we did, we just into the denominator the sign was minus between the real and imaginary part, then we will multiply with its conjugate, that is 1 plus I, multiply into the numerator and denominator with the conjugate of the denominator part, you can see over here, right? Here 1 minus I, that's why here plus and plus, and this will be cancelled out, so we will have the remaining the same, right? So this will be giving you 1 plus I 2 times whole square divided by a minus b into a plus b, that is a square minus I square, right? Because I is in place of b over here, right? Just expand this. When you expand this, 1 plus I square becomes a square, 1 plus I whole square becomes 1 plus 1 a square plus b square plus 2I, right? Divided by here into the denominator 1 minus I square is minus 1, so it will become like this, right? And this will give you, and here 1 square and here I square, 1 square and I square, 1 square is 1 and I square is minus 1, so it will be like this, plus 2I divided by 1 plus 1 minus minus plus. Here you can see 1 will be cancelled out, right? And we are left with 2I divided by 2, right? Which can be written as 0 plus I, because only I remains. So the complex number z equal to 1 plus I by 1 minus I can be represented into its standard format like this, z equal to 0 plus I. Then what will be the modulus? Modulus is very simple. Modulus is root over of x square plus y square. Real part whole square and 1 minute. Modulus is nothing but root over of real part whole square, that is 0 square, plus imaginary part whole square, that is 1 square, because for I nothing is there, 1 is there, right? So this will be coming as root over of 1, and root over of 1 is nothing but 1, right? So modulus is find out as, modulus of this complex number is find out as root over of 1, which is equal to 1. So in this way modulus is calculated, right? Now what is the argument? Argument of this complex number is theta is equal to tan inverse imaginary part by real part. Imaginary part was 1 and real part was 0. That means tan inverse of 1 by 0 is nothing but infinity, right? Infinity. So we can say that yes, tan of theta will be infinity at 90 degree. So the argument of the complex number 1 plus I by 1 minus I is equal to nothing but the value of theta, which is coming over here as, when you see that infinity, you got that theta is nothing but 90 degree or pi by 2. So this is the value of argument for the above complex number, my dear friends, right? So in this way we can solve multiple questions. Okay, if you want I can take another one from the NCERT, 1 by 1 plus I. Similarly as I did for here 1 plus I is there. Okay, let me solve it quickly. Okay, the question number third for today. Okay, the basic understanding we are explaining over here, my dear friends. So I will take up into the deep, we will take some tougher questions also into the subsequent class. So z equal to 1 plus I is there. Okay, how to find the modulus and the argument. Okay, so here into this, any complex number should be represented into the form of x plus iy. That means some real part and some imaginary part should be separated. For the imaginary part, I is always there. So this z equal to 1 by 1 plus I is not into its standard format. Is not into its standard format. This is not like this, right? Then what we will do? We will convert this into a standard format. Then just take this z, the complex number which is given to is z equal to 1 by 1 plus I. As I said, multiply the numerator and denominator with its conjugate, right? As we did in the rationalization. So it is 1 minus I multiplied with 1 minus I into the numerator and same number into the denominator, right? And this will be the fraction, right? Now into the what is the meaning of rationalizing? Because into the denominator we have a plus b and a minus b. So this will be giving you a square minus b square, right? Like this. B is I over here, right? This is b, and into the numerator we have 1 minus I. So this will be giving you 1 minus I divided by 1 minus minus 1. 1 minus minus 1, because the value of I square is nothing but minus 1, right? So this will be giving you 1 minus I divided by 1 plus 2. 1 minus minus 1, that is 2. So this will be like this, right? And if you consider it into just divide 2 separately to the real and imaginary part, it will be like this: 1 by 2 minus I times 1 by 2. So here 1 by 2 and 1 by 2. One here real part is 1 by 2 and imaginary part is minus 1 by 2, right? So we got our real and imaginary part. Then just write the complex number z equal to x plus iy. That means x is the real one, that is 1 by 2 plus iy. But here you can see imaginary is having minus sign. So that means minus I by I into 1 by 2, that is I by 2. So this is the standard form of complex number, which is just find out for the 1 by 1 plus I, which was not into the standard format, right? Now if this is the standard format, that means 1 by 2 minus I by 2, then it's very easy to calculate the modulus. If you remember, this one is modulus of z. Here it was y and here it was x, right? So for this, what is the modulus? Root over of x square plus y square, that means 1 by 2 whole square plus minus 1 by 2 whole square. You've taken the real part and imaginary part into the bracket and under the root, a square of this, right? As we did for this, root over of x square plus y square is your modulus. This is mod z, right? Now this can be calculated very easily, right? 2 can be taken as common from here, and under the root we have 1 1 plus 1. So this will be coming as root over 2, root over 2 by 2, root over 2 by 2, which can be written as, sorry, it's visible now, root over 2, which can be written as 1 by root 2. So the modulus of this complex number 1 by 1 plus I is 1 by root 2. Here you can see. So in this way modulus is find out. Now what is the value of theta? The argument theta is nothing but tan inverse of imaginary part by real part. What is imaginary part? Imaginary part was minus 1 by 2. Okay, just write minus 1 by 2 over here, and real part is nothing but 1 by 2. So write it over here. So this will be giving you, this will be cancelled out. That means tan inverse of minus 1. So we need to say when this will be minus 1, when this will be minus 1, right? Tan theta is minus 1. So this will be, if you see into the plane, it will be all sine tan cos, right? So tan will be minus 1, 1 will be with the value for 45 degree, right? Then we can say that yes, this is pi by 4, but it's minus, right? Minus implicate that, minus implicate this, it's not theta equal to pi by 4, it will be minus pi by 4, right? This minus, so that 1 is the value for 45 degree, so it's pi by 4, and minus is there, so it's minus pi by 4, right? So this will be the argument, right? Argument of z is minus pi by 4, right? When we see the representation over here into the argument plane or the into the complex plane, then we will see how to represent this minus pi by 4. Okay, the location of that point into the xy plane or Cartesian plane or the Gaussian plane can be, it will be not like over here, right? It will be something like this. Okay, we see the representation. Okay, because into this quadrant it can be negative, right? So not here, because it will be pi plus something, right? It can be come over here also into the fourth quadrant also. So we'll see the representation separately into the next class. Okay, so just leave this one. Okay, we will see the just only the modulus and argument for today's class. Okay, so thank you so much for watching, students. Be connected. Take care. Bye bye. See you. Happy learning. See you into the next class. Take care.